In this video, I'm just doing a few more examples of implicit differentiation. So for each of the following, we want to find the derivative implicitly because these are implicit functions. The x's and the y's are all on the same side of the equal sign. So the derivative of x squared is simply 2x. The derivative of y squared would be 2y, but because y is the dependent function, and we know that because we know that we're looking for dy dx, and whatever is up in the numerator here is the dependent function. It's the derivative of the dependent function with respect to the independent function. We have to tack on the y prime here. And then the derivative of 5 is 0. Now we need to solve for y prime. So subtracting 2x to the other side, we have this. And then dividing by 2y, we have y prime is 2x over 2y. Those 2's cancel. So y prime is simply x over y. So the important thing to remember is anytime we take the derivative of the dependent variable, we have to multiply that by y prime. Okay, the next one, this one looks a little more complicated. So we have a product rule here. These two terms are being multiplied together, so we have a product rule. And I'm just going to rewrite this function a little bit to make it a little bit more appealing. I'm going to rewrite this as 3xy minus 1/3 x equals 2x to the negative 1. Okay. So all I did was I took x to the positive 1 and moved it up to the numerator. And I wrote y over 3 as 1/3 y. Oops, that should be a y. So for the first part here, we have to use the product rule. So I am going to let f of x be equal to 3x. And the derivative of that is 3. G of x, I'm going to let be equal to y. And the derivative of that would be 1y prime. So we want f prime, which is 3, times g, which is y, plus f, which is 3x, times g prime, which is y prime, minus. Now, the derivative of minus 1/3 y is simply minus 1/3 y prime. And then the derivative of 2x to the negative 1 would be, bring the negative 1 down, times 2 is negative 2x, and subtract 1 from the exponent to be minus 2. And that is the derivative. But of course, we now need to clean it up, simplify it. We have y prime in two terms. So we want to combine those and take this term that does not have a y prime and move it over to the other side. So that is going to look like this. 3xy prime minus 1/3 y prime equals, and I'm going to rewrite this as negative 2 over x squared minus 3y. Now we need to factor out the common factor of y prime. And so when I do that, what I'll be left with is 3x minus 1/3 equals all of this. And then we need to divide by this into the other side, so we have the y prime isolated. So y prime is equal to negative 2 over x squared minus 3y, all divided by 3x minus 1/3. All right, well, we have a complex fraction that we would like to simplify. So what's in the denominator of the little subfractions, an x squared and 3? So we're going to multiply the numerator and the denominator by 3x squared. Multiply by 3x squared, 3x squared. And what we're going to have when we multiply 3x squared by this first term, the x squareds cancel. I'm left with simply minus 6. And in the second term, I'm going to end up with a minus 9x squared y. In the denominator, 3x squared times 3x is 9x cubed. And then 1/3 times 3x squared, the 3's cancel. So I left with minus x squared. And that would be my derivative right here. Simplified. Okay, one more example. This is another one that's going to involve the product rule, but we have the product rule twice. So let's start with the derivative of x squared is 2x. And then minus, we have to do a product rule here. So without writing it all out, I'm going to take the derivative of x, which is 1, times y, plus x times the derivative of y, which is y prime. And so all of that is in here. That's my product rule. Equals 5 times, now we have the product rule here as well. So again, without writing it all out, I'm going to simply take the derivative of my f, which would be 2x, times my g, which would be y squared, plus my x, which is x squared, times the derivative of y, which would be 2y, y prime. And so now we have y primes here and here. And so we have to clean this up quite a bit and solve it for y prime. So first of all, on the left-hand side, distributing this minus, we have a minus y minus xy prime. Multiplying the 5 through, we have 10xy squared plus, another 10 x squared y prime. Now, these two terms have a y prime. I'm going to bring this term over here and this term over here. So I will have 2x minus y minus 10xy squared equals 10x squared y prime plus xy prime. Factoring out the y prime on the right-hand side, we are left with 10x squared y plus x. And we have all of this over on the left-hand side. And now we want to divide both sides by this. So my final answer should look something like this. And I'm going to put the y prime over on the left-hand side. So we're going to have 2x minus y minus 10xy squared all over 10x squared y plus x. And that is my derivative.